Hi, we're going to learn a new way to determine an empirical formula of a hydrocarbon. And a hydrocarbon is something that contains hydrogen and carbon, may also have oxygen in it and in some cases nitrogen, but this is called combustion analysis to determine the empirical formula. So let's go ahead and see what we do. So first of all, you've got your sample and you add oxygen to it because we know in all combustion reactions, one of the reactants is O2. And so once we go ahead and we put that oxygen in and we heat our compound up, and it's going to combust to form what all combustion reactions form, carbon dioxide and water. And so we've got these U tubes here, and there is material in here that will absorb all the water, and another tube that will absorb all the carbon dioxide. And then any unused oxygen will leave the apparatus. And so if we know the mass of the U tube before the combustion analysis and then after the combustion analysis, we'll know how much water was produced, and we can do the same thing to figure out the amount of carbon dioxide that is produced. Now, again, this has to be a complete combustion, and we just measure the increase in the mass of those tubes to figure out how much water and carbon dioxide were produced. All right, so we have to make a few assumptions. We're going to assume that all the carbon in that original compound that was combusted is converted to carbon dioxide and trapped in that second tube. If we do that, we can calculate the mass of carbon that was in the carbon dioxide, and that will equal the mass of the carbon that was in the compound. Then we're going to assume that all the hydrogen in the compound has been converted into water and it's been trapped in that other tube. And you can calculate the mass of hydrogen in the compound from getting the mass of hydrogen in the measured mass of water. That's a lot of words. So I really think that we're going to be practicing this and it'll make a lot more sense. Also, if your compound contains oxygen, oxygen's a little trickier because you're adding O2 as a reactant and you're not adding a measured amount. So if the compound contains oxygen, you're going to calculate the mass of oxygen in the original compound by subtracting out the mass of the carbon and the hydrogen from the total mass of the original sample. So here we go. Let's give this a try. So here we go. So isopropyl alcohol contains carbon, hydrogen, and oxygen. And so I like to write myself this little generic formula. I don't know the formula, so I just put all my elements in there. And combustion, it's going to react with O2. We can't write a balanced equation because we don't know what our subscripts are. Okay, well, we got some important information up here. We got 0.255 grams of our original sample. That's important. You have to know how much you start with. We get 0.561 grams of CO2, and we get 0.306 grams of water. Okay, so let's go ahead and see if we can come up with the empirical formula for our hydrocarbon. All right, so the first thing we have to do is we have to get how many grams of carbon were in our original sample. So here's what we're going to do. We're going to take the 0.562 grams of carbon dioxide. The molar mass of CO2 is 44.01 grams. So that's the mass of a mole of carbon dioxide. And then you can see that there is 1 mole of carbon in a mole of carbon dioxide. And let's go ahead and see how many moles that gives us of carbon. I have my calculations over here to the side. I get 0.0127 moles of carbon. And then I would like to know how many grams that is. And so I'm going to go ahead and multiply that by 12.01 grams per mole. That's the molar mass of carbon, which gives me grams of carbon, 0.153 grams of carbon. So we know in that original sample, we have 0.0127 moles of carbon and 0.153 grams of carbon. Okay, water has an extra step in here. We know that a mole of water has a mass of 18.02 grams. And here's the tricky part, that there are 2 moles of hydrogen and 1 mole of water. A lot of people forget this step. In carbon dioxide, it was a 1-to-1, but in water, it's not. And then we get our moles of hydrogen. And so I did this earlier. I get 0.034 moles of hydrogen. Okay, now let's go ahead and convert that into grams of hydrogen by multiplying it by 1.01 grams per mole, which is the molar mass of hydrogen. And let's see, what do I get for that? 0.034 grams. Okay, now, how are we going to get grams of oxygen? We can't just, look at the oxygen in this and this, because remember, we are adding a whole bunch of oxygen. So let's go ahead, and we know that our entire sample had a mass of the isopropyl alcohol was 0.255 grams. So that 0.255 grams was the mass of our sample, and that was carbon and hydrogens and oxygens. Okay, let's subtract from it the grams of carbon and the grams of hydrogen, 0.034 grams of hydrogen, and we end up with our grams of oxygen. Hopefully, I'm not really sure why my tablet is making me write weird like this, but hopefully you're writing down these numbers a little clearer and you can follow along better. The sample mass was 0.255 grams minus 0.153 grams. That was carbon, and 0.034 is the grams of hydrogen. And so when we do that, we come up with, let's see, 0.068 grams. That's 0.068 grams of oxygen. And now let's go ahead and convert that to moles, because we know for an empirical formula, we need moles of everything, and this was a 6 down here. Okay, so 0.068 grams of oxygen divided by 16 is going to give us our moles of oxygen, which is a very small amount. It's 0.00425 moles of oxygen. Okay, we have moles of carbon, we have moles of hydrogen, and now we have moles of oxygen. Now it's just like the percent composition empirical formula problem. You have moles of all of the elements. So what are we going to do now? We got moles of them all. What are we going to do? We're going to divide by the smallest number of moles. And so our moles of carbon, again, was 0.0127. Our moles of hydrogen was 0.034, and our moles of oxygen was 0.00425. The smallest number is oxygen, and so we divide everything by the smallest number. So oxygen becomes 1, and hydrogen becomes, let's see, that becomes an 8, and this divided by 0.00425 becomes 3. Okay, so these were nice and close to whole numbers, so we rounded. And so our empirical formula for isopropyl alcohol is C3H8O. Now, if we had the molar mass, we could find out if this were the empirical formula was the same as the molecular formula, and I believe that it is. But we weren't given a molar mass in this problem. All right, so we got the empirical formula. All right, here's another practice problem. So why don't you guys give this a try? You have 11.5 grams of ethanol, and you're going to get 22 grams of CO2 and 13.5 grams of water. What is its empirical formula? All right, so if you have done this video, and if you can do this problem, you should be able to get the bonus on the next test. Bye.